everyone. This is Bill Maher, and you are listening to Inflection Point, which is a podcast brought to you by Catholic Men for Jesus Christ. I'm excited to be here once again, and I have an amazing guest in my mind. I'm in the medical field, coming over from the UK, and Mark Lintern, who has published an amazing book, The Cancer Resolution, Cancer Reinterpreted Through a New Lens. It's a book that is sort of pulling up floorboards. And it's looking at this condition of cancer in a very different light. And I think this is going to be around for a long time. The book won the Bibo Award, which is the best indie book award for 2023. It's really a phenomenal book. It's also like a reference library in itself. Mark, I'm not gonna lie. I'm in the middle of this book because I keep going back to other parts and so forth. So it's a phenomenal job. And what I want everyone to know is that Mark's path, that his journey is extremely unique. Before we aired the show, I mentioned to them, in a lot of ways, he reminds me of Augusto and Michela Adoni, who were the famous Italians in the 1980s that came up with Lorenzo's oil to treat their son with ALD, and it's a therapy that's been used all over the world. These were lay people that suffered from this terrible condition in their child. And through sheer, purpose and motivation, they tore into the literature and they came up with an amazing theory. And I think, without spoiling the thunder there, that's exactly your story, Mark. You were diagnosed with a form of cancer some time ago, and this is what propelled you into really, as I said, pulling up floorboards and coming up with a whole new theory on cancer. Is that a fair intro?
Yes, and first of all, thank you, Bill, for that lovely introduction and for having me on your podcast. It's a real pleasure to be here.
Likewise.
Yes, I did. I developed cancer at a very young age, and I was confused by that. So I asked my oncologist why I developed the disease. I thought I was healthy, and he couldn't tell me. He couldn't tell me the DNA mutations that allegedly caused my cancer. So I did a bit of research, wanted to find out more. And as I did that research, it became obvious to me that the underlying mechanisms driving the disease were still elusive. And scientists were having trouble trying to identify a clear DNA pattern that could explain the disease. And then shortly after that, I had surgery, so I had it removed, and I didn't carry on my research until a couple of years later when a friend of mine, she developed cervical cancer. So I delved back in and tried to offer suggestions as to maybe different views, alternative treatments. And through that process, I came to hear about different theories of cancer, which I'll mention in a moment, in order to help her just highlight that there were other options available to her. Unfortunately, she went with the conventional side of treatment and passed away within the year. And then from that, I was quite frustrated. I was obviously very angry and upset. I developed quite a lot of research on the subject. I thought I would put that down in a little booklet form so that I could provide that with family and friends, or to family and friends, just in case they got diagnosed. And then that would help them understand that there's this number of different perspectives and possibly other treatments that you could utilize in line with conventional treatment to improve your survival outcome. So, of course, I'd already done basically a year and a half, and then I went down a rabbit hole and made a number of connections, and 8 years later, I've written a new theory of cancer, motivated by this desire to understand more and the death of my friend, really.
Yeah, it's first things first. We're not giving medical advice, right? Obviously, talk to your doctor. But you do have a wonderful book now, if you're willing to get it. We're going to provide links to Mark's book in this podcast. I would give it to your doctor. Purchase the book for yourself and purchase one for your doctor because, medical school, and I've been in medical industry for over 25 years in pharmaceuticals and medical devices. Medical school is funded by industry. It's either pharmaceutical or medical devices. So once you have disease identification, it becomes, all right, what's the drug or what's the procedure? And what is lost, especially with billing issues and all the things that they have to do, the paperwork as a doctor, they don't have time to dive into the research. They just don't have the time to do what you did over the last 8 years to try to put your head around all the prevailing theories and other research because you're going to get into some interesting things on pathogens and so forth. That's a bit different than your traditional oncology. So again, bring this to your doctor and just realize that a lot of these cancers, the 5-year survivability is really horrendous. I have a dear friend who just passed of lung cancer. He was
Oh, sorry to hear
diagnosed in
that.
2017, and it was in the lymph nodes. It metastasized. And, I met with him in the hospital, and I've done a lot of research on cancer as well, nothing like you, Mark. And a lot of what I've pulled out is that if you as a layperson can be motivated and work with your doctor and do your part, I think of it as doing your part, that's diet and lifestyle, targeted supplementation. And my gosh, I wish I had what you put together back then. What happened to him is his 5-year survivability for his cancer was like 5%. And he ended up within a short period of time, those tumors in the lymph nodes was gone within a month or two of a lifestyle change. And the tumor in his lung was down to like just barely visible by the end of about 4 years. And this is before he even went on any kind of therapies or anything like that. And then he had a bad bout of pneumonia. They went on prednisone for 6 months, and he got a shot. Leave it at that. And all of a sudden, everything came back, and within a 8-month period of time, he was dead. And this is after 5 years of doing phenomenal. So 5 year survivability can be very challenging. I think what you're offering to people is you're offering them empowerment. So I want to frame it that way, that each person has the ability to dive into this. And so much of what you're going to suggest is things that can be augmented. So it's not even necessarily saying don't do what your doctor says, but you can certainly augment what the doctor's doing and maybe get a much better outcome. Is that fair?
Yeah, that's pretty much it in a nutshell, Bill, to be honest. So, yeah, there's not really much more to add to that apart from to get a little bit more into the detail.
Well, let's talk about the prevailing theories and then we'll get into yours. What right now, if I'm going through medical school and I'm taking my oncology courses, what am I learning about cancer?
Effectively, first of all, I just want to let everyone know that there's at least 7 different theories of cancer, which many cancer patients don't ever get to hear about from their oncologist. So when a medical student will go through medical school, they will generally be taught the prevailing dogma, which is that cancer is a genetic disease. It's only after they question that side of the argument, that interpretation, once they've been in practice for a while, that they start to even notice that these are the theories. I mean, when you look at the medical textbooks, they most of them don't even mention, say, for instance, the metabolic theory. Some of them do, however, it's a very small chapter, not even a chapter, sometimes just a page mentioning that there is abnormal metabolism in cancer cells. So the problem I found with my research was that most oncologists, while they're all trying to do great things and help as many people as possible, their heart is in the right place. They're thrust into a system that effectively has tunnel vision based on one paradigm, one view of the disease, and that is that cancer is a genetic disease. Now, the other problem with that is that it's presented to the public and even presented to these medical professionals that the DNA theory, or the somatic mutation theory, to use its proper phrase, is factual. It's proven. However, it's not proven by virtue of the fact that there are at least 7 other theories, and there's no cure for the disease at the moment. Those 7 theories exist because scientists do not agree on the underlying mechanism that drives the disease. Now, cancer patients need to know that and it's important to understand that there are different theories out there because treatments are developed from cancer theory. Now, when you understand that, the question then becomes, if I'm aware of many different theories, I don't want to get bogged down in all the detail. How do I determine which therapeutic approach from which theory is going to be the most beneficial to me? Well, there are effectively 10 hallmarks of cancer that were put forward by Douglas Hanahan and Robert Weinberg in 2000, and later updated in 2011. And these 10 hallmarks are essentially shared traits between all solid cancers. So a cancer cannot be categorized as cancer until it shows these particular traits. So because this is a consistency of the disease, each theory is essentially attempting to explain all of these hallmarks. So if a theory identifies a particular underlying mechanism, through that mechanism, it would need to explain all 10 of these hallmarks. And if it can do so, it's most likely identified a key mechanism driving the disease. And then, if that is again the case, then the treatments associated with that mechanism that target that mechanism are likely to be fairly effective or very effective. So each theory is trying to explain these hallmarks. The more hallmarks that can be explained signifies the accuracy of the theory. Now, this is the important point. The DNA theory that most mainstream oncologists subscribe to, because that's what they've been taught through medical school, that is the underlying mechanism driving cancer. In my analysis, the DNA theory can only explain around 2 of those 10 hallmarks, which is why this propelled me onto this research path, because it became apparent to me that there wasn't a complete and consistent explanation for the cause of cancer through this mechanism of DNA mutation. So we can only explain 2 of the 10 hallmarks, suggesting there's more. It's not necessarily suggesting that the theory is incorrect. It's suggesting that we haven't yet identified correlations that matter. When you look at the metabolic theory, which is essentially its rival, the metabolic theory can explain at least 7. So we've got a distinct difference between the potential accuracy between the metabolic theory and the somatic mutation theory, or the DNA theory. Now, proponents of the metabolic theory, such as Professor Seyfried, suggest that it can explain all 10. Now, I've got contentions with that, which we can go into. However, as it currently stands, the metabolic theory is essentially the most accurate mainstream cancer theory there is. And that argues that cancer is actually a metabolic disease. So the metabolism of the cell is abnormal. That cancer is not a genetic disease, and the genetic aberrations we see are a result of the metabolic dysfunction that is occurring. So the metabolic disease offers metabolic treatments. So by my estimation, looking at the hallmarks of cancer as a measure of accuracy, oncologists should at the very least be offering metabolic treatments alongside the genetic treatments they're offering. At the most, metabolic treatments, in my opinion, at this point in time, and in the opinion of Professor Thomas Seyfried, metabolic treatment should be the standard of care.
Yeah, can I interrupt you there for a second, or
Of course you can, yeah.
point out the neat thing about the metabolic theory is, and by the way, you have a chart in your book where you list all the theories of cancer, and then you list all of the different hallmarks, and then you line up where they fall short or where they hit the mark. And to your point, every theory, save the one that you're purporting, misses the mark on at least some of those hallmarks. The metabolic theory is fascinating because for people that don't know what that is, it's basically dysfunction in the cell for metabolism, which occurs in the mitochondria. And as Seyfried explains, the mitochondria stops actually utilizing oxygen, and the cell then reverts to an ancient pathway to make energy through fermentation. So the metabolic theory, what's fascinating about it is the treatments are so cheap. Basically, cut your glucose down or just eliminate sugar, right? Because that would ferment a cell and make energy, and a tumor is going to grow. And go on temporary intermittent glutamine blockers, because the amino acid glutamine will also power fermentation. So the only drug you would need is a glutamine blocker once in a while, whatever that schedule is, and you're going to cut sugars out of your diet. And that's something you can control. That's what's so great about that theory. But you take it a step further, and I'll leave it at that. But I wanted everyone to understand what the metabolic theory was, and that the therapy is so simple.
Absolutely. And there's other things you can add into that type of therapy, fasting, for instance, and maybe other drugs. I mean, Professor Seyfried also adds in membendazole and fenbendazole, I think.
Antifungals, yeah.
Well, they're actually antiparasitic drugs, but they also double up as antifungals as well.
They do.
So that's the interesting thing. There's a theme going on here. So just for me to track back a little bit and just explain, going back to those hallmarks. The reason why this discussion today is so important, and thank you for putting this forward, Bill, is that the theory I've produced is the first to explain all 10 hallmarks. So that suggests that I've identified a key mechanism that hasn't been identified before, that if targeted can probably, as you said earlier, improve the efficacy of the treatments that are currently in use and offers other treatment options to cancer patients. So this is a very positive, offers hope. But the other thing is, and we haven't touched on this yet, but my background is in graphic design. So specifically, obviously, I'm not a medical scientist. I've not been trained in this field. It's all self-taught. So as I was going through my research, I noticed that there are a number of other key features associated with cancer, such as iron overload. And I thought, well, if I'm going to be taken seriously, I need to actually explain all these other features. So I identified around 20. There's actually a few more that I explain in my book, but I identified 20, and most of these are not explained by the mainstream theories either. So I thought to myself, if I've definitely got something solid, I should be able to explain all these other 20. And I do so in the book as well, which adds further validity. And then at the same time, once I'd done that and I'd finished the theory, I thought, well, how do I get this out into the scientific community and into the public community and have credibility that way? So I teamed up with a cancer charity in the UK called Yes to Life, pitched my theory to them, and they were very interested. And they said, well, what we can do, what your theory needs is to be critically scrutinized through the scientific process. So we arranged together an event that happened in February 2023, which was where we got a panel of 10 cancer experts together, and I presented my research in front of that panel over a period of 6 hours in front of an audience, a live audience of over 200 medical professionals. And they criticized the theory. I debated them on key aspects of the theory, and they were able to vote on these key aspects of the theory throughout the 6 hours. And the accumulation of the voting ended up being 7.4 out of 10. That's a confidence rate. So 10 was absolute confidence, 0 was no confidence. So 7.4 was a remarkable achievement for someone like me presenting such a new radical theory, which is quite radical compared to the other theories that are out there. And that basically validated my theory, if I can put my teeth in, and suggested that my theory is relevant to the sense that it warrants further investigation, which is now what's happening, which is fantastic. So so that's as far as it stands in terms of the accuracy and the validity of my theory, and why I think it's important we're having this discussion today.
Well, let's kind of unpack your theory a little bit. What is the cancer resolution, the cell suppression theory?
Okay, I'll try and keep it as short and concise as I can. To first go back and look at the other theories. So there's 7 other theories out there. And how I view this is that they all suffer, unfortunately, and they're brilliant. And of course, I've stood on the shoulders of giants. I wouldn't have been able to come up with my theory without research that scientists have done. However, all those 7 theories, they all suffer from the same flaw, I believe, which is that they all come from the same perspective, and that is that cancer is a disease of cell suppression. So they all assume that the cell has gone rogue, or the cell has become damaged, and the cell is at fault. So we've all got to target the cell. Okay, so the cell is, our own cells have become our enemy, in a sense. My theory is a completely different paradigm, and that is that cancer is a cell suppression disease. The cells are still working to your benefit. They're trying to help you out. However, they've been commandeered by certain pathogens, in particular fungal pathogens, that are actually controlling and suppressing key functions of the cell, that then leads to the symptoms that we see and call cancer. So it's a cell suppression disease and not a cell malfunction disease. That's the separation in these paradigms. So my theory is separate from all 7 of these other theories. Now, how I got onto this concept was that I was studying the metabolic theory, and I realized how important that was. However, there were some contentions with the metabolic theory. It couldn't explain three of the main hallmarks. And one of those hallmarks is why mitochondria, or this energy switch to the Warburg effect, occurs. Okay, so Professor Seyfried is offering the explanation that OXPHOS, which is the oxygen pathway within mitochondria that produces energy, is damaged. So that mitochondria can't produce energy in that pathway anymore. So that the cancer cell is forced to revert to glycolysis, the backup energy system, which is an ancient pathway. That produces loads of lactic acid, and then cancer evolves from there. The rest of the hallmarks evolve from there. Now, the contention is that they can't find the specific damage or a pattern of damage within mitochondria, or within mitochondrial DNA, or within the DNA within the nucleus, that can explain why this transition occurs. So I recognize that this transition, this Warburg effect, is key to cancer, and it's almost pivotal to identifying the underlying cause. Because the question I then posited to myself was, what else could potentially cause the Warburg effect? Is there something else that can do that? And then I stumbled across a paper looking at infection. And that paper described how an infection enters the cell and how the cell reacts. And as the cell reacts, it actually switches energy. In fact, the phrase that was used in the paper was, a Warburg-like effect is instigated because this is an anti-infection response. And of course, this set alarm bells ringing for me, and I did a lot more research, and I thought, well, hold on a minute. This suggests that fungi, or even bacteria, are potentially involved in the suppression of key aspects of the cell, and the cell is intentionally switching. But I've also heard about infection causing cancer. So I went back to the medical literature, because a number of people would have turned around to me when I've presented my theory and said, oh, we've already covered this. Infection causes cancer. We know that about 20% of cancers are caused by infection of bacteria and several viruses, oncogenic viruses. And when you look at that, you realize that we're back to this cell malfunction paradigm, in that those microorganisms are thought to cause cancer because they damage, or they affect the DNA of the cell. They damage the respiration. So that damage then leads to cancer. So it's the damage that they cause, not necessarily the pathogens themselves. Those pathogens could be killed, but the damage that they inflict then leads to cancer. So we're back to this paradigm of cell malfunction is the underlying cause, and the cell has gone rogue. So my paradigm is that I realize that infection triggers the Warburg effect, and then ask the question, well, what if the infection is sustained? Will the Warburg effect be sustained? So evidence then confirmed that this was the case. So now I have an explanation essentially for the Warburg effect. And then I found some important work done by Dr. Robert Navio in America. And he talks about how cells respond to danger, so toxins and infection. Specifically infection, when he explains this, he explains it like this. An infection is identified by the cell. So what the mitochondria do is that they actively suppress OXPHOS. Now, Professor Seyfried says OXPHOS is damaged and defective, which is why this energy switch occurs. But Dr. Robert Navio is highlighting that mitochondria are healthy, but they choose to use the oxygen they would use via the OXPHOS pathway to produce ATP energy. They choose to use that oxygen instead to combat the pathogen by creating free radicals.
That's the key.
And that then encourages the cell to use glycolysis, because glycolysis then supplies the cell with the ATP it needs to fight off the pathogen and create an inflammatory response, which can aid the repair caused by the damage.
And just survive. Otherwise, the cell's going to die if it's diverting the oxygen to treat the pathogen. It's going to die if it can't make energy.
Absolutely. So this is a really beautiful explanation of this process that provides an alternative explanation for the Warburg effect that we see occurring in nearly all solid cancers. So the mitochondria aren't actually damaged based on my theory. And what happens is that the pathogen invades the cell, and it's successful. It's not always successful, but it's successfully invading the cell. So it now is able to suppress the cell death mechanisms of the cell. And I think this is the key point. Mitochondria aren't just energy creating organelles within the cell. They do so much more than that. They defend the cell against pathogens, for instance, and they regulate many other different aspects of the cell. So they're so important, including apoptosis, the cell death
Apoptosis, yeah,
mechanism.
cell death.
So when you then do the research to find out, okay, do these pathogens that I'm saying cause cancer and trigger this Warburg effect, are they capable of blocking the cell death mechanism? Yes, they are. And they do this in order to sustain themselves within the cell. So what you actually now have is a cell that is reverted to a proliferative state by forcing sustained glycolysis, because the mitochondria are trying to combat the pathogen. And the mitochondria are now blocked from causing cell death. So you have a proliferative state, cell death cannot occur. Cell death would be the last resort in order to defeat the pathogen. So now you have a situation where you have an overgrowth of cells, which is a tumor. So this process provides an alternative explanation for the Warburg effect that the metabolic theory is suggesting, and also explains many of the key mechanisms that we find occurring in cancer that the metabolic theory can't explain.
Yeah, why the cell won't die now, and it'll just keep propagating because it's being that process is being suppressed by the pathogen. There's a precedent in parasitic infections. There's a whole school of medicine of helminthic therapy where people have autoimmune conditions. They'll get like ringworm and different worms because as they propagate in your body, they suppress the immune system, and all of a sudden some of the effects of the autoimmune condition goes away because that vector, if you will, that pathogen is actually suppressing the heightened immunoresponse of the autoimmune condition. So it's sort of the same thing that these fungal pathogens are basically suppressing the cell's ability to obviously die in the case of apoptosis. It's their oxygen that normally uses to grow is being redirected to actually attack it, and there's this battle that's going on. So the heart of your whole theory is really there's a pathogen at the base of everything.
Absolutely, and so this is where the heart of the cell suppression paradigm comes from, and one of the key aspects of it is that I found when I was looking at a number of studies that were looking into alternative treatments and say the use of organic food compounds, because people obviously talk about changing their diet and how it's benefited them. There are studies where they place these natural compounds, such as bromelain from pineapple or sulforaphane from broccoli, turmeric, even honey, organic honey. And they place these in petri dishes on cancer cells and healthy cells. They don't affect the healthy cells, but then the cancer cell triggers apoptosis. Now, apoptosis, cell death mechanism, the reason why cancer is alleged to develop in the other theories, the other cell malfunction theories, is because that process is thought to have malfunctioned. That apoptosis is defective. That's why the cell can't die. That's why a tumor develops. But here, evidence is showing, well, that apoptosis pathway is actually reinstigated on purpose by the pathogen. So that questions the notion that that pathway is a defective and damaged beyond repair, and it also questions the notion that the cancer cell has developed a mind of its own and is choosing to survive, because it's surviving in situations where extreme damage is being caused by maybe chemotherapy. However, nutrients that nourish healthy cells all of a sudden can trigger that cell death mechanism. Why would a cancer cell that wants to survive, has become, say, another species essentially, choose to suddenly die when it's provided with the nutrients that would normally sustain healthy cells? Doesn't make any sense, unless you view the disease through the lens of my theory. And that is that all those compounds, including honey, which is very interesting, and even silver, they're all antimicrobial. They're all antifungal. So my argument is that while many people can't explain how organic compounds in plants and other foods can have this effect against cancer, my answer to that is, well, if the pathogen is suppressing those functions, those antimicrobials are entering the cell, killing or weakening that pathogen, which then allows the cell to utilize the same pathways that it's been trying to utilize that were suppressed. They're no longer suppressed anymore. So the cell danger cycle is completed. Once completed, the cell or the mitochondria look back at the cell and analyze how much damage has occurred. Is the cell still viable, or is the cell damaged to the extent that it's past a certain threshold where it could damage the host if that cell replicates further? And when that's the case, the cell chooses to commit apoptosis because the cell is damaged to the detriment of the host. So that's one of the main key aspects that highlighted to me that there was this suppression mechanism going on. And then the question, I suppose, for your listeners is that, okay, so I'm suggesting that pathogens are present up until recently, and even now, oncologists, proponents of the DNA theory will say that tumours are sterile, free of pathogens. That's always been the dogmatic view. However, that conception was blown away by Ravid Straussman's work, and now since others who stumbled across pathogens being present in the tumours they were trying to treat and test. And then they did an analysis of deep DNA sequencing on 35 cancers, and they found that bacteria and fungi and viruses exist within all tumours, all cancers. So then the question becomes, well, okay, now this corroborates my theory. Essentially, those pathogens would need to be present in order for my theory to have more validity. The question becomes, are those pathogens present because they've colonized after the event of tumor developing, or are they the actually underlying force driving the disease? Now, I already created pretty much the theory that explained how these pathogens drive the disease. So I'm saying it's the latter, that they do actually drive the disease. And through my book and explaining all the 10 hallmarks of cancer, then the other 20 on top, I detail in it exactly how those particular pathogens are able to suppress particular pathways, upregulate suppressive compounds to suppress the immune system, and develop the conditions of the disease, and why this abnormal metabolism we see occurs.
Are there any risk factors that you've uncovered? Because if this is principally fungal related, are there any patterns that you have seen where someone is at higher risk than someone else?
It's a very good question. I mean, I'm not seeing cancer patients personally, so I can't really
Understood.
draw from that data. But what I can share, and the reason why I specifically single out fungi, and don't get me wrong, there's a crosstalk and a synergy between bacteria and fungi and viruses and fungi that
Biofilm,
occur,
sure.
that also add to the complexity of the process. But the reason why I single out fungi is because fungi are eukaryotic. Our cells are eukaryotic. That's a particular cell type. And if you want to look at it in layman's terms, there are essentially, and just be reductive about it, there are essentially two types of cells that make up most, if not all, life forms on Earth. And that is bacterial cells, which are known as prokaryotic cells, and then plants, fungi, and animals, which make up the rest of us, which are called eukaryotic cells. So fungi share the same type of cell structure, and a number of similar pathways are present within the pathogen as they are within human cells, because we share the same cell type. That's why antifungal drugs are a lot more toxic than antibacterial drugs, because there's similar pathways within the pathogen are affected by the antifungal drugs that are affected by us. So that, for one, indicates that the fungal pathogens are adept, and a lot of the research I shows that they are adept at manipulating our cells within the environment of the human body, because they share similarities. The other thing is that when oncologists provide chemotherapy, there's this issue with immune suppression. So there's a threat of bacterial and viral infection. So when they provide antibacterial drugs for any extended period of time, what you see is over that period of time an increase in cancer risk and severity if you overuse these antibacterials. Now there is the risk of that with antifungal drugs. However, when you apply antifungal drugs to a number of cancers, you notice that they appear effective against a broad range of cancers. So antifungal drugs at the moment are being investigated because they appear effective against a great number of cancers, which is not what you get when you apply antibacterial drugs. There are one or two exceptions, such as doxycycline. But when you look at doxycycline, you find that doxycycline itself is also antifungal. So there is also this other correlation between people who are looking at repurposed drugs, such as metformin, statins, and what have you. And there's the Care Oncology Clinic in the UK, and I think in America, which uses 4 drugs, including doxycycline, a statin, metformin, an antiparasitic. And these 4 drugs, when you look at their other properties, they're antifungal. When you look at a number of the other repurposed drugs that are being used and appear to have efficacy, they're also antifungal. So there's this correlation. I know correlation doesn't equal causation, but there's this strong correlation that supports all the other evidence I've got that is all pointing in one direction, and that's to the influence of these fungal pathogens.
There seems to be other benefits too, like for instance, metformin. If you're in a situation where you have a tumor, you don't want to be on anabolic agents, and metformin decreases mTOR, which is your growth pathway, and it upregulates ATP, which is a pathway of autophagy, towards autophagy and sirtuin repair and all that stuff. So yeah, it's very interesting because if you're a diabetic, the studies all show that diabetics on metformin have significantly lower rates of cancer and heart disease, by the way, than someone who's a diabetic that's not on it, for example. So fascinating stuff. And you're talking about a pretty inexpensive agent in metformin, pennies on the dollar, which is another great thing about that. So let me ask you this. You have a friend who just got died. You're not giving medical advice. This is not even for your friend. This is you. You get stage 4 lung cancer. What are you going to do? What are some of the things that make sense to you? Obviously, you're going to go to a doctor, of course. But so much of your theory is giving people the ability to empower themselves. What would be a protocol that you'd put yourself on?
Okay, great question. So in the book, I do provide a potential solutions section, which really details this approach. And essentially, a lot of it is common sense. I follow a lot of what the metabolic theory is suggesting, because we're obviously discussing that cancer cells have abnormal metabolism in that they absorb a lot more glucose than healthy cells do. They upregulate their glutamine levels, which also contribute, and also fat. So I advocate for I would advocate for myself for a metabolic approach, potentially fasting. What you want to be doing is also obviously providing nutrients to the body. You might have a nutrient deficiency. You want to be reducing inflammation. So the tissue organization field theory is one of the other theories which suggests that the reason why cancer occurs is because you've got inflammation of the body, and that inflammation over a sustained period of time causes damage to cells, which means they are unable to signal to each other to suppress growth signals. So I would advocate for, and for myself, would be to reduce inflammation, preferably through diet.
Well, let's talk about that for a second. Let's put some flesh and bones on that. To reduce inflammation systemically, what are some things that someone can do?
Okay, so I mean, you've got initially acutely to use in non-inflammatory drugs, so ibuprofen or what have you. But I wouldn't put necessarily people on that. I mean, I just want to also say that I'm not a clinician, so
of course,
this is not medical advice, obviously. It would be to eliminate a lot of the compounds in your diet that are actually causing the inflammation in the first place. So pesticides. So you would want to go organic. You would want to remove plant-based oils. A lot of them, you got the wrong ratio of omega-3 to omega-6. So you would want to obviously eat as much organic as possible, fresh as possible. So remove processed foods, because they're going to be using a lot of these plant oils. you want to reduce the amount of glucose that you're being consumed, specifically processed glucose again. If over a certain amount of glucose when you consume, say in a number of studies, it highlights that actually you're suppressing your immune system as well as causing inflammation. Because a lot of these pathogens, the cell wall is made from carbohydrate. So when you bombard your body with glucose, what you're effectively doing is you're confusing the immune system, because they're going after elements of the glucose you're consuming rather than the pathogen itself. So you want to eliminate that noise. And depending on the type of information you've got, obviously you want to be speaking to your clinician, and they can maybe provide some initial drugs that can help reduce it. If you have inflammation of the brain, for instance, that's an urgent priority. But generally, you really want to look after your body in terms of eating the right food, eating the right diet that eliminates that inflammation. Turmeric is supposed to be absolutely fantastic for eliminating inflammation within the body. So it's just learning what you can from preferably a dietitian that understands these processes, or a nutritionist, and accommodate that with your microbiome. So to just move further on from this, just to give you an overall summary, I would essentially try and block some of the pathways. I would eliminate inflammation, but I would also consider fasting and what have you, but also an antifungal approach to the treatments that are being offered, as well as eliminating the inflammation in the body, but seeing how they could work synergistically with other off-label drugs such as metformin, or even using berberine, which performs a similar act as metformin, the drug, and from a more natural component.
There's also a dihydroberberine now, which is a new form of berberine that's even a little more potent. Dihydroberberine. It's interesting.
Absolutely. And because we're talking about pathogens, it's specifically, you need to be looking after the microbiome, and I would advocate for trying to test and identify which pathogens are present within your body. If anything, the ones that are present in your tumor. I'm talking about taking antifungal compounds or antifungal drugs. They're not specifically the answer, because they are toxic, so you've got to be careful about that. You've got to think about your liver. But it's not just a case of let's just try any old antifungal or compound that we know, off-label compound that can target pathogens. We want to know what pathogens are present. So we want to be understanding what we're targeting here. So testing is key, and keeping your microbiome healthy. So largely a plant-based organic diet will essentially do that, but you need to understand the health of your microbiome first, because your microbiome might be more geared to consuming meat, for instance. So you might not be able to break down some of these compounds that are in plants. So yeah, it's a broad range of basically trying to adopt kind of lifestyle as well. You're talking exercise. Exercise is fantastic for eliminating excess glucose within the body, oxygenating your mitochondria, providing them with the ability to combat the pathogen. And also along those lines, you might want to also consider oxygen therapy, such as hyperbaric oxygen therapy, ozone therapy, because these alternative treatments are also antifungal in the sense that they increase the virility of your immune system and stimulate your mitochondria to become more active, which can benefit you against cancer.
You're driving more oxygen into the cell, into the body.
You also have, just quickly, infrared saunas are an interesting adoption, because what we find is that they stimulate mitochondria to produce, forgive me, I forget the name of the compound that we produce when we go to sleep.
Melatonin.
That's it, thank you. So most of the melatonin we produce are produced by mitochondria, not the pineal gland, which is interesting. The pineal gland only produces about 5%. Now, infrared saunas actually stimulate mitochondria to produce melatonin, and melatonin is a fantastic antimicrobial. So that's why sleep is incredibly important as well. So it's a combination of all these things, just looking after your body, being really healthy, adopting potentially pro-oxidant therapies if you want, but discussing with your oncologist when to do that, and eating really good food, because what I've found in my research is that those compounds I mentioned, sulforaphane and bromelain and what have you, they are metabolized by a particular enzyme within the body called CYP1B1. That enzyme is only regulated in tumors. So it's almost like a targeted therapy in the sense that that enzyme metabolizes those antimicrobial compounds, polyphenols and what have you, found in all these organic foods, into compounds that can kill these pathogens within the cell. So there are two scientists from De Montfort University that actually identified this enzyme and identified that natural compounds from organic foods are actually broken down by these enzymes, and they called these compounds in plants salvesterols. So you can actually buy salvesterol supplements, which are like compacted natural compounds, these polyphenols in food, that you can take for this enzyme to actually then use those antimicrobial compounds to effectively target cancer cells. So that's an interesting story. People might want to actually investigate salvestrols.
Yeah, it's fascinating because you mentioned the biome too. A lot of the things pomegranate is a great example. If you have the right bacteria, when you drink pomegranate or eat pomegranate, you're going to make what's called urolithin A, which has a wonderful effect on your mitochondria, mitophagy, which is similar to autophagy in our cells. It's the recycling, if you will, of old mitochondria. So there's this interplay that's really fascinating. You mentioned inflammation too. You mentioned turmeric. There was a study published some years back I found fascinating. They were looking at TNF alpha, tumor necrosis factor alpha. It's obviously a nasty inflammatory marker. And they looked at all these spices. It's a wonder all these Indians don't have the same cancer rates. They use a lot of spices. They found that turmeric, yes. They found that rosemary. They found that ginger. They found that cloves. By the way, all the spices they looked at had somewhat of an effect on TNF alpha, but those four I just mentioned obliterated TNF alpha. So just taking some of these things and putting them into your diet, putting pineapple into your diet. I know a lot of times companies sell quercetin, which is a senolytic now, they're discovering, but they're putting bromelain with it. So, I mean, you can easily get these phytochemicals, whether from your food or targeted supplementation, and actually do some pretty amazing things, I think.
Yeah, it's really interesting. And from my journey, I published the book last year, I've now got a Facebook theory discussion group. So anyone can join that at the group. And it's really interesting because a lot of the people in that group, they're either trying to treat their own cancer or they're treating a friend's cancer. And that it's incredible how much knowledge they have, how much research they've done. And I'm just in touch with a number of people who've actually gone down the conventional route and then have taken on board alternative views. And then they provide a protocol, in particular, say, for instance, glioblastoma. And they now have no evidence of disease by following particular protocols. And there is a pattern here of using off-label drugs, but also using antifungal compounds, but also using this process of reducing inflammation, as I've just said, using organic food and the compounds present in a lot of plants that are antimicrobial. So it's really interesting to see this. And I'm seeing a completely different perspective, and I'm learning from these fantastic people in the group. So, I would also advocate for people joining other groups. There are a number of other groups out there that support cancer patients and help each other discussing potential treatments and what they've used. And everyone knows that in these groups that these aren't randomized controlled studies that are being discussed. These are patients that are actually using these compounds in real time to try and see what works and what doesn't. And that's not to say that what works for one person will work for you. It does depend on your microbiome, your blood group, all different aspects of your health at your given moment in time and the stage of your particular cancer. So, and even I would say the type of fungal pathogen and maybe bacterial pathogens that are present. So not all antifungal drugs are going to affect all fungal pathogens. So this is why you need a nuanced approach, but at the very least, you should start by eliminating the inflammation and providing your cells with the nutrients they require and the antimicrobial compounds in organic food, and exercising to eliminate this abundance of sugar we are pumping into our bodies these days. You do that, you are basically creating an environment that is inhospitable to the fungal pathogen that is present. So by restricting these metabolic pathways, you're also restricting the primary fuel that the pathogen requires to survive within the cell. That's why it's there. It's using the glucose that the cell is now absorbing in abundance for its own survival. And then when that, and this is the key, sometimes when that is blocked, you block just glucose. If you're not focusing on glutamine as well, the cell will upregulate glutamine in order to account for that ATP shortfall and all the other metabolites it needs to grow. The pathogen will be absorbing that glutamine as well. And what it does is it transverts that glutamine into glucose, because that's its primary food source. It does that with fat as well through the glyoxylate cycle within the
Any
fat.
particular fats that are more problematic?
I don't have an answer on that. I would need to look into that in more detail. Sorry, I don't have an answer for
That whole world is being turned upside down. It used to be stay away from saturated fats. Now people are like, well, actually you need saturated fats, right?
Yes.
And obviously the ratios of omega-3 to omega-6, we know that we want to flip that. That's typically a problem. Now they found there's a C15 oil now that seems to have amazing effects on body. We have so much to learn. But I think what you're doing with this Facebook group is phenomenal, because people are sort of searching for answers, and maybe they're finding some. I just think that if I have a diagnosis of cancer, I'm going to want to support my doctor. And I think that's the secret to all this. You got to play your part. You can't go to McDonald's. You can't be having Big Macs. You can't be having Jumbo Cokes if you got a diagnosis of cancer. In fact, you shouldn't be doing that anyway. Once in a while, hey. But the reality is we're getting toxically overloaded. I mean, I did a urine analysis. I've got glyphosate in me, and I've got atrazine and all that. Now, fortunately, I was in like sort of the yellow, so my doctor was like, "Wow, you're actually in pretty good shape for this country, because it's in the rainwater, it's everywhere." And when you take something like glyphosate, which doesn't break down, it's a herbicide. They tried getting an indication as an antibiotic with that problem. The problem was the glyphosate killed all the good bacteria and left the bad ones to live. So you ingest this stuff and you're obliterating your bacterial biome. There's some studies suggest that 95% of Americans, talking in America because we have worse, you got much better regulations in Europe than we do here, but 95% of Americans don't have Akkermansia, which is a keystone species of bacteria that actually mines and promotes the growth of the mucus layer on your lining of your gut. And if you don't have that, you're going to have disruption in your gut. You're going to have that whole leaky gut permeability syndrome, which causes inflammation and causes a lot of the problems we have. So we're bombarded. So to your point, trying to avoid obviously produce that's not organic. Try to go grass-fed, free range, all that kind of thing, and try to keep good things in your body is the first step. Even exercise has been shown. If you exercise, you actually increase your bacterial diversity, believe it or not. So
you also increase the number of mitochondria that are present within each cell, which if they are a defensive mechanism, then that's only going to be beneficial. I think one of the studies I got in my book is that exercise can reduce the risk of cancer by up to 60%. So that's quite incredible.
Which kind of points to the fact that this happens in the mitochondria, because that's directly what you're affected. What are your thoughts on methylene blue? Because that definitely has some mitochondrial effects.
Yeah, it's used for photodynamic therapy, isn't it? And as far the little research I've done on it, because I'm hearing all these different potential treatments that people are using and compounds within that group, it's quite hard to keep up with the number of them. They're quite many. Methylene blue is antimicrobial, as far as
It
I'm
is.
aware. It's antifungal.
It'll kill malaria.
Um, yeah. So and utilizing it with photodynamic therapy appears to be an effective strategy. I think it's a pro-oxidant in that sense. So if you're producing high level of free radicals, what your free radicals will kill the pathogen within the cell. That's the whole point of why the mitochondria produce them. Immune cells do the same thing. They'll phagocytize a pathogen, bombard it with several different compounds, but one of the main key compounds is free radicals. They're
Yeah,
literally, like, you want to look at them as bullets that are being. They don't kind of work like that, but for ease of use, they're like bullets being fired at an enemy. So yeah, methylene blue in that sense.
it's interesting. And when you mention basically for people, just go outside, take methylene blue. There's a company called Troscriptions. They make a trocar that you kind of shove up here and it just dissolves, so your whole mouth doesn't turn blue. But
Right.
it just, you do that and you go outside for a little while or use red light or something like that. There tends to be a synergy there, is what you're saying.
Yeah. Yeah. Absolutely.
Any particular foods or supplements or even drugs that someone can talk to their doctor about for fungal side of this specifically?
Um.
You mentioned
Again,
sulforaphane.
I'm a bit reluctant to go, and I don't want to be seen as
Fair
giving
enough.
like advice on which particular drugs.
Fair enough.
Uh, but certainly, I've got a number of drugs. I mean, DCA is one that's been bandied around. Um, However, uh, there is toxicity involved with that needs to be resolved. Professor Seafood talks about Don as being a glutamine inhibitor, but then there's issues with that safety of that as well. So um,
I mean, these discussions you would have with your doctor anyway, for
yeah,
sure.
and I've got a chapter in my book which is chapter 13, and that provides a number of the drugs, just highlighting the number of the drugs that are actually used, and the reason why they seem to be effective in the sense that they're antifungal and they're anti-glycolytic drugs as well. So there are a list there, but I'm specifically not qualified to say which ones are better at this stage. So
Sure,
I'm just a
sure.
little
No,
bit reluctant
understood.
to, but the information is there in the book, and that's how I'm presenting it. It's information. I'm not giving advice. It's information for other people to. I'm bringing this to their attention, so that then it can be discussed um, responsibly with a clinician.
Wonderful, wonderful. I appreciate this. Are there any final thoughts or are there anything that you want the viewers to know about? Are you going to be on any shows or are you working on any projects? What do you got going in front of you?
Yeah, well, I'm trying to do two things, which is essentially disseminating the theory and the book to cancer patients, so that they can make informed decisions. So podcasts is one of the things. So thank you very much for having me on. But the other thing is, in the background, I'm because of the event that I did in February and the acceptance from a number of scientists of my theory, I'm now working with a number of scientists and clinicians. We meet every month, and we're trying to determine a way of testing the theory. So we're looking at a phase 1 clinical trial. However, this is all voluntary. Um, so we're trying to establish the type of trial that we want to do to identify not only if the fungal pathogen is the underlying cause, but also specific antifungal protocol that can be used across the board in a lot of cancers to help people. So I'm really trying to push the envelope on this, because um, I don't want to just write a theory and that's it. The whole point of this is, if my family and friends get cancer, I want them to be they want to be fine after it. So regardless of whether or not my theory actually turns out to be true, I'm not bothered. If I'm wrong, I'm not. I don't care about that. What I want to do is, I'm really pushing this idea to try and test the theory to prove it, wrong or
Sure.
right. So I'm really pushing down this route of talking to scientists. I've got a couple of potential investors from different fields interested in maybe funding these trials. I'm speaking to scientists. I'm going to conferences. and speaking to them on the side. But again, for me, this is all voluntary, and it means that I'm struggling financially
Sure.
to do this. I'm doing this off my own back. So I'm having to work between my graphic design job to pay the bills and then try and focus on this as best I can. And it would be ideal if I could work on it full time so that I can speed up this process.
I appreciate you saying that, because if there's anyone going to be listening to this when this is aired and they would want to help Mark out, email us and we'll certainly forward your information to Mark, because you're advancing the discussion, and that's what needs to happen. And what I love so much about what you're doing is I just feel like it's empowering the patient. So much of this theory gives the patient power as well, as opposed to, what do I do next? Oh, yeah, there's a plan, work with your doc, of course, but there's simple things you could do in your life to actually potentially, address what this theory is expressing could very well be the cause of cancer. So it's exciting.
Thank you for that. I do have a GoFundMe page that can be found on my website if anyone does want to help me out there, and that would be very nicely received. Thank you.
Oh, I appreciate it, Mark. This was such a pleasure. I'm so glad we had the opportunity to have you. I'm jazzed by your book. I love it.
Thank you.
Like all of us, I've had cancer in my life with friends and family members. So this is one that we're not going to get away from, and what you're offering to the world is remarkable. You are the Augusto Adone of 2023. So thanks so much, and we'll certainly keep in touch.
Thank you very much, Bill. It's been an absolute pleasure speaking to you. I really appreciate what you're doing. Thank you.
Likewise. And everyone, thanks so much. Thanks for joining us on Inflection Point. We will see you guys soon, and God bless.